Hello guys, Sergey Metelsky here from BlenderUs.com, and this is the second part of our procedural Christmas lights tutorial. In first part we created our dynamic wire rig, and in this part I'm going to show you how to distribute our light bulbs along our spline. So first off, we need a geometry, and to save you some time, I already created this light bulbs. And these are three different colored light bulbs here that are that belong to the same group, light bulb reference. You can call it whatever you want. So let's go back to first layer. So first of all, we need to create an instances of our light bulbs, and let's go for example 30. Okay, and we can create an empty mesh objects here. Doesn't matter because we're going to set the geometry data blocks from our group light bulb reference. So we also need this group here, light bulb reference, which will output our three light bulbs here. So to get it scattered along our spline, we need to retrieve an information about a certain point along our spline, and for this purpose we're going to use evaluate spline node, which takes a single spline as an input, and then it returns a single location and tangent values for our spline. So I'm going to show it to you right now. Location, let's make it bigger and color it something like red, and yeah, you can see right now at the 0 parameter value we have our point at the start of the spline, and as we modify this parameter we can see this point moves along the spline. So no matter actual spline length, it will be always normalized to 0-1 range, just for the sake of convenience, of course. So what we need to do is we need to divide this range, I mean maximum value of this range, which is 1, by overall amount of our objects. So for the sake of convenience, let's say we have 10 light bulbs and we divide 1 by 10, we have 0.1, right? And so first bulb will be at 0.1 position, then second bulb will be at 0.2 position, then third one will be at 0.3, etc., until it reaches the value of 1. But evaluate spline node only takes one parameter at the time, so we need to create a loop subprogram to iterate over a range of float values for each light bulb. So we go to our loops, and oh, it's already created. I'm gonna scrap it, and I'm gonna create another loop subprogram here, which I'm gonna call just as this node, evaluate spline loop. And it's very simple. It takes a single spline and it iterates through a float list, and this float list will contain, as I said, parameter values for each of our light bulbs. So spline, float, and then we add our evaluate spline, plug in spline right here, our float parameter here, and output two vector lists, another vector list, and location here, tangent here, and we're going to call it respectively something like location and tangent. And we're going to need tangent for properly rotating our light bulbs along our spline. Okay, so let's go to our groups. Here's our spiral generator, and we're gonna, just rearrange it so get it out of the way. Okay, we're gonna create a new group, which we're gonna call distribute light bulbs group. Okay, and first off we need our instances here. So object list instances, then another object list which gonna hold data blocks and mesh data blocks for our light bulbs. I'm gonna call it something like data holders. This is kind of a minimal set for our group to work. So first off, we need to get a length of our instances list. So, and then as I mentioned before, we need to divide 1 by the total amount of instances. Divide, okay, and then we need to generate a float range. And this is going to be a list of steps for our parameter. So amount of length here, and this is what, oh yeah, we need to actually plug in, we need to actually create an instance of our subgroup distribute light bulbs. So our instances, okay, and let's go back. We're gonna delete this, we don't need this. And so we got ourselves a list of parameter values for our evaluate spline loop subprogram. I'm gonna show it to you right now. So 30 values for our parameter value. Okay, so here we're gonna add our evaluate spline loop, and we're going to feed, oh yeah, an actual spline. We need an actual spline here. So how could I forget this? This is the minimal set. So spline, float list, and we have ourselves a vector list. And right now, as you can see, it's 0 because we have to refresh. Oh, because we have to feed an actual spline here, like this. And it works fine. And if we visualize it with 3D viewer, you can see that we have positions for our light bulbs. And now we can fit these locations into our object transform output. So first off, our instances goes here, then XYZ and location. So now we have empty objects scattered along our spline, and we need to set data for our instances, okay? And for this, we are going to retrieve data from our data holders objects. So we need to create an expression node, and I'm going to write a very easy and very simple expression. So okay, let's fit it in here, and for the sake of convenience, we're going to call it ob list, which stands for object list naturally. And we're going to type in list bracket and ob data for ob in ob list close bracket. So what this line does, it actually retrieves data blocks out of this object's list and put it in another list. So so it says create a list of objects data blocks for each object from this object list. Okay, so it's pretty self-explanatory. So now it's important thing to do. We need to explicitly set the output type for our expression node to generic list. A generic list is a list of values that are not fit any standard animation node types, such as vector or float, integer, string, etc. So and what it outputs a, okay, let's execute it. Let's go back to the program. It outputs a list of 3 data blocks, and it's not actually data blocks, it's just the pointers to these data blocks. But it's only 3 of them, while we need 30 of them. So that's why we need to repeat this list several times until it reaches the length of 30, or whatever our actual amount of instances is. So for that, we need to create repeat list node, set it to length mode, loop, and we need to feed in here the actual length of our instances and our list here. Okay. And what this outputs, naturally a list of 30 pointers to our data blocks. And it's important to understand that this is not actually creating any more data blocks inside blend file. It only creates pointers to these data blocks. And so now we can map them to our instance objects. So let's create attribute output node, feed our instance objects in here. We want to modify data value. We have multiple values to input, and our list goes here, and we instantly see that our instances are now holding these light bulbs data. And to visualize it, I'm going to switch to material, and you see our group of light bulbs are now scattered across our spline, just as we wanted to. Let's say we don't want these light bulbs to be ordered, you know, as green, red, blue, green, red, blue, and so we want to randomize them, you know, just to give it a more random look. So we need to put here another parameter, which is going to be boolean. We call it randomize. And here we are going to create a fork where we're going to fit different lists here depending on whether it's checked or not. So for this purpose, we are going to add a random list. So this list is just simply repeated several times, but it stays ordered. And this node will create a randomized list out of any other lists. So we're going to fit the length here again, our source, and to once again, to give more artistic control, we're going to add a seed value here. Seed. Let's feed the seed right here. And now we need a switch node, which will output one of these values depending on, well, condition. Okay, and our condition will be this checkbox here. And if randomize checked, if true, it will output randomized list, and if it's unchecked, naturally it will output our kind of ordered list. Okay, and this goes here. So let's see what it does here now in our main node tree. And ordered, randomized, ordered, randomized, and you know, we can even animate this seed to make these light bulbs go crazy if we wanted to. Okay, now you might notice that these light bulbs are facing upwards, and it's not very realistic. So that's why we have our tangent value here, or tangent. I don't know how it sounds correctly. Okay, never mind. Oh, okay. Let's arrange this so it will be nice and clean. Okay, we don't need this anymore. Let's give it some space here, and so tangent is a vector value, while we need an rotation Euler value. So to convert direction, which is this tangent, we need to use direction to rotation, this first one here. So we fit in this tangent here. So these are a number of tangents naturally for each light bulbs, and we're going to enable X, Y, and Z rotation in our object transform output node, and we're going to feed our Euler rotations right here. So, and we see that now light bulbs are kind of facing the direction of our spline, and to fix that we just need to change a few few settings here on direction to rotation nodes. So we set this one to X, this one to Y, and direction Z -1. So now they're facing correctly outwards from our, kind of normal of our surface. But they're all kind of strictly facing outwards, all in the same kind of manner. And we want more natural look, so we want to a little bit randomize these rotations. Okay, so here's that one little nuance, is that we can't actually create a multiple random Ehlers. We can create one, so this Euler wiggle outputs just a single value, while we need a number of them per each light bulb naturally. So we're going to use some trickery here. So because for some reason, I don't know why, vector vector wiggle supports this multiple values output. We are going to use vectors converted to rotations actually. So yeah, so we need a number of this wiggled vectors. Once again, length of our instances goes here to count. We're also going to use seed to better control randomness, and yeah, output multiple vectors, which we are going to convert vector to Euler use degree. And now this resulting Ehlers, we are going to simply add to this direction to rotation Ehlers. So rotation, Euler math, this goes here, and this goes here, and finally here. So, and let's check it out. Oh yeah, I forgot to expose this actual wiggle amplitude to our group settings. So, and we're gonna call it random rotation. Okay, now let's hide this, and we're gonna and we're going to join this nodes in a frame, which we're gonna call rotation. Okay. Yeah, so let's check it out. Now, last thing is we need to control this overall scale of our light bulbs. So that's the easiest one. We just need to create another float value, which is going to call scale. And we just need to create a new vector from this single value here, and simply feed it to our scale right here, and set it to something like 2. No, yeah, like this. So let's see. Yeah, here's our light bulbs scattered along our spline nicely. So that's basically it for the technical part. And the last thing, we just might want to give some more control over this setup in our viewport to minimize our interaction with actual node setup. And for this, we are going to create a few simple type nodes. So integer for amount of bulbs, amount, or count, I don't know, actually have. Okay, so 30, let's feed it in here and display it, show it in the viewport in advanced node settings here. So let's switch to our, yeah, here it is. Okay, now if we want to change our appearance of our light bulbs on the fly, we can change the actual groups, which holds objects that represent the shape of our light bulbs. So in order to change it fast, we need another group object input, object group input. Yeah, that's correct. And once again, show it in the viewport and fit it in here. And now let's collapse this. We don't need to change it right here anymore. So once again, a Boolean value randomize, show it in viewport, fit it in here. And a few, just a couple of float values for rot random x. Oh, damn it, not here. Rot random x and respectively z. And these are go to combined vector x z goes here, and we're gonna show them in viewport. What else? Yeah, it's probably, oh yeah, the scale. Okay, so number, float, scale. Boom, right here. Show viewport. And now we can simply unite these to something like viewport control. Okay, so it's nice and clean here. And we can, close our node editor, and we have full artistic control over it. Okay, scale, yeah. Full artistic control over this setup in a viewport. So, yeah, as you can see, it's fully interactive. So yeah, that's finally it. So I hope you guys liked this tutorial. I hope you found it useful, and there's a lot of room for improvement, and I'll be glad to see if you somehow made this setup even better. Thanks for watching, and happy blending, happy holidays, happy new year, guys. See you next year with more awesome tutorials. Bye bye.